So we can go ahead, I think, and get started. So, welcome. My name is Krista. You haven't seen me for a while, probably. I did the very first live streaming show way multiple months ago, so it's great to be back, to be here and talking with you again, doing one of our planetarium live shows. So if you saw the very first one, you might remember me talking about our night sky. But today we're going to be looking at two of our gas giant large planets. They are visible in our sky tonight and for the next few months as well. So we're going to be exploring two of our gas giants, Jupiter and Saturn, in the sky, a little bit about them, how we learn more, and again, at any time, if you have questions, I will try to answer as many as I can myself. I'll leave some time at the end where we can talk about any questions I haven't gotten to, but you can also share any questions you have in the chat box. Mike is also here with us, our planetarium manager. He will be in the chat answering questions as well, so feel free to add those in the chat anytime. So anytime I look away, I'm just looking over at my other screen where our image is, so promise I'm not ignoring any of you. But we're going to go ahead and start with our sky, right? Best place to start. So we, of course, are showing you the sky as it will be visible this evening after sunset from right here in Jersey City specifically, but everywhere on Earth that's at our same latitude, so the same horizontal distance from the equator. Anywhere on Earth at this latitude, this is the same night sky that you're going to see. The time just might be a little different. Or even if you're a little off, from what I've seen from all of our guests where you're joining us from, this is pretty much going to be a very similar night sky. So I have us right here, probably about an hour and a half or so after sunset. There's a lot that's visible in our sky, of course, but main things that you can see likely are our moon. So it's a great night to view the moon and the planets because tonight the moon and Jupiter and Saturn are all right next to each other. So it's a great time to step outside and view these objects. So I'll go ahead, again, we'll just put up a nice little circle here around our two planets, right? Thankfully, they are really nice and bright. You might notice, though, that they are in the south. We've got the southern sky here. If you ever need to know where the south is, so you may remember this little trick from previous streams if you've seen them, or you might know this yourself, but if you can find the 7 stars of the Big Dipper, the last 2 stars in the cup point you directly to the North Star, and the North Star tells you you're looking north, so that's why we call it that. So it tells you that you're looking north, and then to find south, you just turn yourself all the way around from the North Star. So it's a quick little handy way to find our two planets in the southern sky tonight. So Jupiter is going to be the really bright dot to the left of the moon. We'll go ahead and start by exploring our largest planet. It's going to be visible if you don't have a chance to spot this planet tonight. It's going to be visible for the rest of the year. We zoom up here with our telescope. You can see some of the features that really make Jupiter so beautiful, those different stripes. And if you have a telescope or even some binoculars, you might see some little dots to the left and the right of Jupiter. So I'll pause this right here because these are what we call the 4 Galilean moons. Now, you cannot see these moons with your bare eye, but if you do have a telescope, you should be able to see little tiny dots. And this is actually where they will be tonight. This is their position. Just like our moon goes around the Earth, the moons of Jupiter orbit around the planet as well, so they will not be in this exact position every time you look at Jupiter, but this is where they'll be tonight. We are going to take a look at a couple of these moons during the show today. And as you may know, these are not the only moons that Jupiter has, so there's quite a few, but we're just going to take a look at some of them. As you may have guessed, these are called the Galilean moons because they were discovered by Galileo in his first telescopes that he invented. That was all the way back in the 1600s. So really cool that we were able to spot other moons orbiting a different planet all the way back in the 1600s. So, again, those are going to be visible if you have extra technology that might help you get a closer look. But if you don't have binoculars or telescope, don't worry. That's why you're here for our show today. So what we're looking at right now, I just kind of wanted to show you, since we're going to be talking about our outer planets, and I think I mentioned outer planet before. So that just means the planets really past the asteroid belt. That is this kind of circle shape full of little dots. This is where a lot of our asteroids are found. When our solar system was forming, our planets came together, and pretty much any leftover pieces that didn't get made into a planet fell in this specific area. There's another asteroid belt way out past our outer planets too, but the inner one here is kind of separating the planets that are smaller and made mostly of rock from the planets that are larger and made mostly of gas and liquid. So the past the asteroid belt, which is between Mars and Jupiter, that is where we start to see all of our large, which was why we call them gas giants, because they're really big and they're made mostly of gas. So something else cool, we're going to take a look here at Jupiter. I want to pause real quick because you might notice there's a kind of weird dark line here, and this is Earth. We're going to show you just size compare of how many Earths can fit. So while I'm going to talk about a feature, if you have a guess, how many Earths do you think can fit inside of Jupiter? Go ahead and put that guess in the chat. What do you think? How many Earths can fit inside of Jupiter? So you have a little scale here, so it's more than one Earth can fit inside. So what do you think? So while you're entering your guesses there for me and Mike to see, want to point out there's kind of a weird dark line that you can see going across Jupiter. And as you may know, there are planets that have rings, and when I say planet with rings, Saturn is probably what comes right to mind, but Saturn is not the only planet that has rings. So it turns out that Jupiter has rings also, so does Uranus, and so does Neptune. All of our gas giant planets have rings going around them. But the main thing is, I'm seeing a lot of awesome guesses, by the way, of how many Earths can fit inside. Seem to be actually on the right track here. So very cool, very good guesses. All of our gas giant planets have rings around them, but as you can see, the rings of Jupiter are very thin and they're really, really, really hard to see. So we're going to get another look at the rings of Jupiter in just a second, but I wanted to point out that's why that thin line is there. So when it comes to how many Earths can fit inside of Jupiter, we can actually fit 1,300 Earths inside, so 1,300. So seemed like a lot of you were guessing about 1,000, so great job. That's a lot of Earths. This is a really, really big planet, and you can see that you can fit 11 Earths just across the diameter. So this is a really, really big planet, which is why we call it a gas giant. But that gas is very important because when you're looking at these clouds of Jupiter, you're not looking at a solid ground. We're actually looking at clouds, the atmosphere of Jupiter. Now, of course, we can study this with telescopes and with our eyes, but to get an even better look at Jupiter, we send satellites and different things out to study the planet. So this one here is called Juno. Juno is currently orbiting around, I'll just pause it, we can take a look at Juno here. It's currently orbiting around Jupiter. It's still active. This launched in 2011 and made its way out to Jupiter, and it arrived there in about 2016. And ever since then, it takes oval-shaped paths, getting close to Jupiter. It doesn't go into the atmosphere, but it gets close, takes pictures and different measurements to help us learn how the atmosphere moves, what it's made of, and we're trying to find out what is underneath. Because I know this is a question that a lot of people have. What is under the clouds of Jupiter? So Juno is trying to help us answer that as it gets nice and close. And by the way, it has to go millions of miles away on its trip. The reason it doesn't stay really close to Jupiter is because there's a lot of radiation there. So this is just a view of, again, we have to get through the asteroid belt to make our way out to Jupiter. I do want to say that we have sent a lot of different satellites and spacecraft out to Jupiter, going through the asteroid belt. Quite a few have gone there. The asteroid belt, you may be thinking of something like Star Wars, where there's rocks and things all over. The asteroids in the asteroid belt are about 60,000 miles apart from each other. So they're actually really well spaced out. And for the most part, we can track, there's jobs in the astronomy field that help to track where all of these asteroids are, how they're moving, and most of the satellites we send out are able to detect whether something's in its way. That's kind of one of the protective measures that these agencies take. But for the most part, we don't need to really worry about things like Juno crashing into an asteroid on its way to Jupiter. So we do plan for that. So about the atmosphere of Jupiter, again, Juno's trying to help learn more about it. So by different observations, we have detected things like thunderstorms and lightning, and all occurring in this kind of raging, swirling, deep atmosphere on the planet. So Jupiter's atmosphere, and you can see it kind of swirling around here, and I'm going to pause it just one more time, because all of these different stripes, different colors, we're still trying to figure out why Jupiter has these amazing colors and stripes, and what's causing them. We think that underneath this atmosphere of Jupiter, we think that there may be a core of metallic liquid hydrogen way down in the center that is kind of like conducting electricity, and it's causing Jupiter to have this very active magnetic field, and having the atmosphere, all of these stripes are swirling around. You could kind of see it. I'll play that again. You can see how the clouds are moving and swirling. And part of the reason for that is because Jupiter's spinning around very fast. Even though Jupiter's the biggest planet, right? Remember, 1,300 Earths can fit inside. Even though Jupiter's the biggest planet, it has the shortest day. It takes about 10 hours to spin all the way around. So because of that really fast spin, there's a lot of electricity probably happening in the core, the center of Jupiter. It's making this really large magnetic field. That's a lot of radiation, and that's part of the reason why Juno gets close, but then it has to fly away to kind of protect its instruments, and then comes back nice and close again to make measurements, and then goes far away. So again, we don't know for sure what's underneath of that atmosphere. We actually don't know for sure. We have a lot of different ideas, but we're actually not able to see under the atmosphere. So you might remember from, if you were here during our Venus planetarium program, if you were here for that, we are able to use radar to kind of peer underneath the clouds of Venus. But Venus's atmosphere, while it's very thick, it's not nearly as deep as the atmosphere on Jupiter. The clouds of Jupiter are so deep we are not able to see through them. Something called the Galileo spacecraft actually dove into the clouds to try and help get a measurement, but the winds are moving so fast on Jupiter. And again, there's a lot of pressure, there's even heat as you get down deeper, that spacecraft didn't last very long. It wasn't able to survive long enough for us to see what's really under those clouds. So we do have some ideas of what the inside could be, but what we get the most accurate measurements on are how those clouds in the atmosphere behave. Now, there's a big red spot here on the surface of Jupiter. So we, of course, cleverly named this red spot the Great Red Spot. It is great. It's basically a hurricane that is bigger than our entire planet. So Earth could fit inside of the Great Red Spot. This is basically a giant hurricane that we have seen going for pretty much since we found Jupiter. So we've been watching this storm for at least 150 years, but maybe even more, maybe 400 years. So how would you feel about a 400-year-long hurricane on Earth? Probably not great. So scientists are trying to figure out, how has this storm been going for so long? This is a giant storm. But like hurricanes on Earth, those hurricanes stop once they reach land. On Jupiter, there's no land to stop a hurricane, so that could be a reason why it's still active. And we have seen the storm shrinking. So in the past, in our past 100 years or so of watching this, we've actually seen the storm shrink, and it's predicted maybe it'll go away in the next 20 years even. So that's something that Juno is definitely helping us watch and try and learn more about. And Jupiter, and the winds of the Great Red Spot, they can get up to like 400 miles an hour at the edges. So it's a very kind of big old hurricane. And in this view here, actually, since you might be able to see the rings of Jupiter, but the reason that they're so hard to see, and you may not have known that they were even there, the rings of Jupiter are really made of dust. They're super thin, they're really hard to see, and they're not very shiny, so we actually didn't really know about them until we sent a spacecraft out to get closer to Jupiter, and it's the same type of thing for Uranus and Neptune. Their rings are pretty much made of dust, and that's very hard to see in the darkness of space until you get closer. The rings of Jupiter weren't even detected. Like I said, we sent something past Jupiter, it turned around, and so the sun was in the background, and it lit the rings up. That's really the only way that we're able to see the rings. You need a nice bright light there to kind of make them visible. Or if we actually use a different type of light called infrared, the rings of Jupiter actually glow a little bit. So that's another way that scientists are able to try and learn more about those rings. So I've talked a lot about Jupiter itself, but because it's the biggest planet, it's also able to hold a lot of moons around it. So like I mentioned, there are the 4 Galilean moons. These are the 4 biggest ones. Jupiter does have a lot. It has about 79 moons total. So definitely has quite a few out there. We're still learning. We're still observing. Some of these moons were discovered somewhat recently because a lot of them can be pretty small. They take a long time to orbit around the planet, so we might not be able to find some of them until they get to the exact right spot for us to notice them. So I'm just going to talk with you about a couple of my favorite moons around Jupiter. This moon is called Io. I know it looks kind of gross, right? It looks like a disease or something, but Io actually has the youngest surface and the most volcanically active surface of any object in our solar system. The reason that Io has all of these volcanoes and things happening is because it's the closest moon to Jupiter, which means that there's a lot of gravity tugging on Io from one side, where you have gigantic, massive Jupiter. And then on the other side you have, remember I said Jupiter has 79 moons, so on its other side there's 78 more moons that all have gravity as well, and they're kind of tugging on Io. So if you want to imagine my head is Io, and you've got giant Jupiter on one side and a bunch of moons on the other, the gravity is playing tug of war with Io, and it's actually causing the planet to kind of be squeezed, and that makes the inside of it hot and active, and it's making volcanoes erupt all over the surface. You can see these giant plumes of how high these things are going. That tug of war can actually move the surface. You can think of it like tides on Earth, but that tugging can actually raise and lower the surface of Io 300 feet or so. So it can be very hot where the volcanoes are. It can be about 3,000 degrees where those volcanoes are erupting. We think the inside of Io is molten, probably molten sulfur, so it might not smell very good on Io. But because there's not really an atmosphere to hold that heat, in other places on Io it can be below 200 degrees. So this may or may not be a place where we can find life. There's a lot of weird living creatures under our oceans by what are called hydrothermal vents. A lot of these moons we're going to talk about may have ingredients for life. So while there's weird things that can occur on our planet, so really hot places deep underwater where there's a lot of pressure, we have found microorganisms and life. So any of these places like Io, where we have different chemical processes happening in really hot locations, maybe things are able to survive. We're not going to know for sure until we can get closer to one of these bodies to find out. So since we're talking about places where life might exist, this is one of NASA's top destinations. So this is a moon of Jupiter called Europa. So this is one of the Galilean moons as well. We think that this moon is covered in a shell of ice, about maybe 10 or so miles thick, and below that ice, we believe there is an ocean of water. It can be 100 miles deep of water. Of course, it's really cold because this moon, doesn't go back a little bit, because that's our next one. Because this moon is covered in ice, we do think it's pretty cold there, but below the shell of frozen ice, we again think that that is water. And using something called a spectrograph and spectroscopy, astronomers have been trying to look at all of these cracks in the ice to see if anything is coming out of the cracks of ice. And we think that we have detected water vapor, which gives us a clue that there probably is an ocean below that shell of ice. So this moon Europa is almost as big as our moon. So if you want an idea for how big that is, we think that these cracks are coming from things like tides on our Earth that may be a lot like Io. Maybe it's stretching the surface a little bit, cracking the ice, which is good because it helps us try and see what's going on under there. So, of course, water is important for life, right? All life that we know of needs water in some way on Earth. So anywhere we find liquid water out in the solar system, really exciting. We think that might be a great place for life to exist. Okay, so that was Europa, the ocean-covered moon of Jupiter. And then we're going to go to the biggest moon in the solar system. This moon is called Ganymede. It's very pretty, right? It kind of looks like it's covered in sparkles almost, and bright splotches. This is the only moon that has a magnetic field, so it has protection from the sun's rays. This one we think is covered with ice at the very surface, and then rock kind of below that. The light and the dark regions are that you see, right? You've got all these bright splotches that kind of look like things were thrown onto the surface of Ganymede. We're still trying to figure out what is causing these light and these dark regions. We think that it's probably just what the parts of the soil are made of, parts of the ice and things. Just kind of a view for how large Ganymede is. So not bigger than Earth, of course. It is bigger than Mercury, though. So there's a couple moons that are larger than Mercury in our sky. I'm just going to pause this right here because that kind of takes us to the end of our Jupiter tour. There's so much that I could talk to you about with the planets and moons and things. I could probably talk to you all day about these. So like I said, if when we get to the end, I'll try to go back and look at questions if I haven't answered your question from our quick tour already. Again, Mike is in the chat if you have questions for him, and I'll try to leave some time at the end to answer questions too. So that is the bright dot that you're going to see in the sky tonight. It should be no trouble finding nice bright Jupiter. And then if you want to spot our next planet, Saturn, it's just to the left. So once you find bright Jupiter, just look to the left. It is visible with your bare eye. You should be able to spot that. And then this is visible through the end of the year as well. When we look at Saturn with a telescope, of course, now we get to those magnificent rings that are very iconic with this planet. And like you might guess, they're probably made of something different than those rings of Jupiter. Remember how hard it was to see those rings of Jupiter there. So we're going to take a closer look at those rings of Saturn. But even from afar, you can see that, like Jupiter, Saturn is covered in stripes, right? It is, again, what we call a gas giant, which means it's really big, made mostly of gas, of that atmosphere. So Saturn, of course, not as big as Jupiter, but you could fit about 700 Earths inside. Now, this is, I think, my favorite feature about Saturn, even more than those rings. At the North Pole of Saturn, there's something really weird going on here. So just like Jupiter and like Uranus and Neptune, Saturn has a very deep atmosphere, and it flows around, just like the clouds and the air does on our Earth. You could even think of it like water flowing around. At the North Pole of Saturn, you might notice there is a shape right here. It has corners, and there's 6 points, which means that at the North Pole of Saturn, there's a hexagon. And this is multiple images taken by the Cassini spacecraft that spent about 13 years orbiting around Saturn and measuring things. Why is there a hexagon at the North Pole of Saturn, right? Remember, this is all gas flowing around. There's no reason why there should be corners when gas is flowing around. We don't know the answer. We don't know the answer of why there is this really interesting shape at the North Pole. Anytime something naturally flows, liquid, gas, anything like that, it never takes a corner turn like that. It always is a nice circle shape. We don't see a shape like this anywhere else in the solar system. So the best idea, or I guess the most current idea of what's going on, is that there's a little storm at each one of these corners that's maybe causing the gas to kind of bank on a turn like that. But as of right now, we're still trying to figure that out. So one of the great mysteries we have about Saturn, and by the way, all the different colors here this is not really what the colors look like. If we looked at this with our eyes, it would be kind of blue and gold in color, I think. But all of these bright pinks and blues and greens are when we look with different kinds of light, like I mentioned, infrared and ultraviolet and things. Different wavelengths of light were assigned different colors to try and also help figure out what the temperature and is there anything weird going on that we might have missed before. So that's why the colors are so kind of bright. So that's the North Pole mystery that we're still trying to figure out. Now let's go ahead and take a look at the rings. So the rings of Saturn, like I said, are different, right? They're really wide. You can fit probably 4.5 Earths across the rings of Saturn. They're very wide, but they're not very thick. We're actually going to fly right into them right here. So I'll pause this because, like I said, they're not super thick. They're about the thickness is about the length of a football field. So very wide, almost like they got stretched out. And as you can see, it's not a solid disc. If I actually back us up just a little bit, from out here, the rings look like a solid disc, like a racetrack. When Saturn was first discovered in the early telescopes, it was thought that Saturn had handles. Like a sippy cup almost. But then, of course, as we got more and more detail, like I mentioned, we sent Cassini out there, flew all the way out to Saturn. That launched back in 1997, and it spent 13 years just studying Saturn. So a lot of the information we have came from this mission. So the rings of Saturn, as we get closer again, they look solid from here, but as we can see, they're not. They're made of millions of chunks of ice, right? So the rings of Saturn are, because they're made of pieces of ice, ice is very reflective, really shiny. The light of the sun bounces off of ice very well. Like when it snows, you might notice that everything seems brighter. So the rings of Saturn being so wide and being made of reflective ice is the reason why we can see the rings of Saturn much easier than the rings of the other 3 gas giants, which are made mostly of dust. So the pieces of ice making up these rings, they could be as small as a grain of sand. They could go all the way up to as big as a house even. We think that they came from something like moons, asteroids, anything like that that got too close to the big planet Saturn and got pulled apart by its gravity, made into millions of little pieces. So I'm going to pause this here because you might notice this big chunk in the middle of the rings. This was an object that we did not know existed until we sent Cassini out to study Saturn. So it turns out that in the rings of Saturn, not only are there pieces of ice, but there are also some moons that just live in the rings. So this moon here is called Pan. I think it kind of looks like a submarine, and I just imagine it swimming through the ice sea of the rings. Pan's pretty small. It's only about 18 miles across, but that's bigger than the pieces of ice. So I know I'm pausing and stopping a lot, but I want to make sure that you can see that in the rings of Saturn, this is Pan's little path. It's pushed the ice out of its way and created its own little pathway in the rings. So before we sent Cassini there, with our telescopes, all we saw were these weird gaps in the rings. We had no idea why those gaps were there. And then as Cassini got closer, it was able to observe there's actually 4 moons that live in the rings, causing these gaps. So we actually solved a mystery by having Cassini fly out there. So a lot of moons around Saturn, right? So just like I showed you the orbits of Jupiter's 79 moons, also wanted to show you the orbits of Saturn's moons. So I'm going to ask you another guess or answer knowledge question. Do you think Saturn has more moons than Jupiter or less moons than Jupiter? So what do you think? And keeping in mind, Saturn's smaller than Jupiter, right? Every planet's smaller than Jupiter in our solar system. So smaller than Jupiter is farther away, right? What do we think? Does it have more moons or less moons? So as the answers are coming in here, I'm kind of seeing both, I think. So for a while, we said that Saturn had less moons than Jupiter, right? Makes sense. It's smaller, has less, able to hold less objects in its gravity. But as of about a year ago, so 2019, it was announced that we found 20 more moons orbiting around Saturn. So now Saturn officially has the most moons. So Saturn has 82 moons. So that doesn't mean that Jupiter doesn't have more. It just means that we haven't found those moons yet. So kind of another reason that we are constantly learning about the objects in our solar system. There's still a lot of questions we don't know, but there, of course, are plenty of things that we are figuring out. So I'm going to take us to a couple of Saturn's moons. So in 2005, Cassini, which that was what just kind of flew to the side, Cassini launched a little probe to land on this specific moon. So this moon is called Titan. Titan looks, if you're kind of looking at this video here, it might look kind of familiar, right? It looks like there's kind of lakes, rivers and hills and things. Titan's really interesting because this is the only moon in our solar system that actually has an atmosphere, a substantial atmosphere. There are some moons that have very thin atmospheres, but this is the only moon with a decently thick atmosphere, and that's really interesting because, right, just like we have our atmosphere on Earth that helps us breathe, and then it contains things that help protect us from harmful rays of the sun and objects that are plummeting, you know, asteroids or little meteors that come to Earth. They can get burned up in our atmosphere. It helps protect us. It also is where the water cycle happens and weather and things. So on this moon Titan, all of that liquid that you see kind of there on the surface, that is not water. So this is liquid methane and ethane, just different kinds of carbon chemicals. And Titan's actually really cold. So it might not look cold, right, because it looks very orange, but Titan's about 300 degrees below zero. So that's not cold enough for this methane to freeze. We do want to try and go back to learn more about, even though that is not liquid water, it is still liquid, and that liquid acts in a cycle a lot like our water does on Earth. It does rain there, we think, and we have, lakes and things. So maybe because carbon is a building block of life, maybe there's organisms that are able to live and survive on this very cold moon. So NASA does have a mission. It was announced that its next destination is going to be to go back to Titan and try to explore more and look for signs of life. And we're going to do so with this spacecraft. It's called Dragonfly, which you might see why it's named that. It kind of looks like a little dragonfly. It's going to actually land on Titan, and it will collect samples. And it's not just going to land and sit there, though. So it's going to pick specific spots, and we'll actually be able to collect samples of different areas. And then Dragonfly is going to take off again and kind of leapfrog a few miles to different spots to explore more and kind of hop across the surface of Titan to try and collect samples to see if there's organisms maybe that are living things, or if there's evidence for past life or maybe future life. So it's basically the first it's called a multi-rotor, so it has a couple different propellers and things. The first thing like this is going to be on a different world, so really exciting. That's not going to launch until 2026, so we do have a few years of waiting to get there, but it's going to be really exciting to explore something that looks a lot like Earth, but just with a slightly different kind of chemical cycle. So again, that was Titan. That's Saturn's biggest moon and the second largest one in the solar system. So this one here is a very interesting looking moon. It might look kind of familiar. It looks a little bit like Europa, the moon of Jupiter. Well, this moon, it is very similar. It's called Enceladus. If I back us up just a little bit here, you can see that it's got very similar cracks, a lot like Europa had. And these cracks have things kind of shooting out. So these are actually jets. And because things are coming out of the cracks of this moon, Enceladus, different spacecraft like Cassini are able to measure what this stuff is. They're able to use different instruments to figure out the composition of what is coming out of these cracks of the moon. And it turns out that that is water. It's icy little particles of water and different kinds of gas as well, because Enceladus is another moon covered in ice that we now really think is covering an ocean. So we think this moon, a lot like Europa, is covered in a liquid ocean. And on the very outside is a shell of ice. The ice on this moon, though, is probably a lot thinner than the ice on Europa. So this might be even as thin as half a mile thick, and in certain places on the moon. So the also really maybe biggest sign that there might be life on this moon is not only is it covered in water, which as we know life needs, but it's also been detected in these jets are particles of something called the silica. And on Earth, these particles can only form in those hydrothermal vents that I mentioned a while ago. So really hot areas in the ocean, deep under the ocean, that is the only place that these silica particles are found. So that tells us that maybe there are volcanoes under the ice in the ocean of this moon, creating these circumstances, and there might be because we also know that hydrothermal vents have life on Earth, maybe there's similar organisms on this moon. Again, we're not going to know until we're able to land on these moons, drill down under the ice, and kind of go exploring in the oceans, but it's another really exciting destination of the solar system that we might want to go back to. So another moon orbiting around Saturn, this is a moon called Iapetus, and it's kind of known as the yin-yang moon. I've heard it described as like the Oreo cookie moon, although it is kind of opposite. Maybe there's vanilla Oreos. But it's really, when this moon was first discovered, it actually was hard to see because most moons of our solar system are what's called tidally locked. A lot like our moon goes around Earth. One side of the moon is always facing the planet. It's revolving at the same speed that it's orbiting. So because of that, as this moon was orbiting around Saturn, you might notice there's a really bright side and a really dark side. Well, as this moon was going around Saturn, the bright side was a lot easier to see from far away than the dark side was. So it kind of looked like there was something that was like brightening and then disappearing, and then brightening and then disappearing. Could only really be observed when the moon was on a specific side of Saturn. And it turns out that that's because this moon has a bright reflective side, and that's because it's covered in ice, right? And then there's this dark side too, which we're not completely sure what's going on there. We think maybe it's picking up some dark particles from another moon that's nearby. or maybe there's has something to do with the heat and temperature of the moon because of it being tidally locked. We're still trying to figure this out. So that's another one of the mysteries, but it's pretty cool how it has this bright side and a dark side on there. And I know that might kind of sound like Star Wars a little bit, and that does kind of connect us to another moon of Saturn. This one's called Mimos, and I bring up Star Wars because Mimos is covered in craters, right? You can see that there's all these chunks. And there's specifically one big impact area. I'm going to circle it here. This is about a third, the whole crater itself covers about a third of the entire moon. So it's actually amazing that this moon didn't blow apart when whatever created this crater blew into the moon here. And amazingly, Mimos didn't break apart. It just stayed there, but it left this big crater. And because of this big hole in there, it looks a lot like the Death Star of Star Wars. But we don't, unless George Lucas has some way to see into the future. Star Wars came out in 1977. We didn't get a nice image of this crater until 1980. So if George Lucas can time travel, I would not be surprised. But as of now, it's just kind of an interesting connection how they look so similar. So that's just kind of an exploration of some of the different features of a couple of those planets that we have in our night sky tonight. I think we have a couple questions left, so I'm going to switch over and try and look at our comments to see if we have any specific questions. I'm just gonna kind of go backwards here. Let's see. And if Mike, if there are any good questions, if you want to put those into the chat. It seems like you're doing a great job answering those questions. I do want to say something I forgot. Because Enceladus is that moon with all the jets spewing out of kind of icy water vapor and things, all of those particles are actually creating another ring of Saturn. So we actually, as we learned more and more about those rings, we actually saw there was a thin outer ring being created because the jets in Enceladus are actually like spewing particles out, and those little particles are kind of forming one of the rings of Saturn. We name the rings just alphabetically, letters of the alphabet, as they were discovered. So they don't really have super interesting names. They're just named the letters A through E as we found them. So let's see. Seeing some good. Oh, I do want to mention. So I've been showing you some different images and videos and talking about a couple of the planets. And I'm really happy to see so many of you here joining us today. This is a really great way for me to kind of give you some space tours and different information, but I am also going to be at the planetarium this weekend, so I'll be there on Saturday afternoon. So if you want to come and see me talk about all of the planets that are visible in the sky or objects that are out in deep space as well, I will be at the Science Center on Saturday in the afternoon. So I'd love to come see you, have you say hi, and let me know if you enjoyed the show. Great. So, oh, great question. Are there plans to occupy one of these moons? So, really great question. As of now, not that I've heard of. As of now, most of these moons aren't really a great place for us to try and live. Like I mentioned, pretty much all of them are below 0 in temperature. There are areas on some of the moons that are warmer. But for the most part, there's not really an atmosphere, and for a moon like Titan, the atmosphere is not oxygen, right? So some moons have a really thin oxygen atmosphere, but there's really not a substantial thing for us to breathe. As far as we know, there's not really any kind of life to to create food and different things for us. And because there's not really atmosphere on these moons, like I mentioned, there's not a ton of protection from the super cold temperatures of space and the rays of the sun. Even though the sun's weaker once you get out to these faraway planets, it's still a lot like going to live on our moon. We'd have to create so many different circumstances to make the moon's livable for us. So kind of the first step is to see, is there life at all? Because maybe we could learn a little bit about how to survive on these moons. And if life is not able to survive, then that's probably a good indicator for us. Great. So I think I'll probably answer a couple more questions, and then I think we'll have to be done for our stream today. So will any of the planets turn into black holes? Deepak, great question. So it's kind of interesting. So Jupiter actually has all of the ingredients to become a star. It has all the ingredients, but it's just not big enough. It was never large enough to ignite into the nuclear fusion processes that make stars. So all of the planets are just not big enough to even become a star. And then black holes come from the most massive stars. So no planets are big enough to become a black hole. So we don't have to worry about it as far as we know. And let's see. Oh, Mirabelle, great question. Why are the moons mostly made of ice? And the main reason for that is because it's really cold. We know, most moons do have pretty much ice. There might be liquid hydrogen and things like that. And it's, when I say ice, it's not always water, right? Like water ice, like we see here frozen on Earth. It might be frozen methane, frozen carbon dioxide, but because space is so cold, a lot of any liquid that would exist is able to turn into ice. So, great question. All right, so that will do it. I want to thank you all so much for joining me on my kind of welcome back to doing the live streaming. So it was great to have all of our questions. Great to have you join us. And I hope you enjoyed the stream. And again, we'll be open. We're open right now, and we'll be open Friday, Saturday, and Sunday. So thanks again, and hope you have a great day.